Yeah.
No, I don't care. This one called closed loop or closed stirrups. I need this shape of this hook or this close or this lock only for torsion. When I'm talking about torsion, I will let you know what is the main purpose for this hook. Okay? But right now, for shear, maybe your stirrups open stirrups. Looks like this. Maybe close the stirrups is the best. This one is the best. Like this. Maybe you have only 2 legs. Like this. Maybe 3 legs or 4. Whatever. I don't care. For any reason, we have very huge shear. And most of the time, your stirrups made from number 3 or number 4. So we need many numbers of stirrups. Your S spacing between stirrups maybe 1 inch or 2 inch. It's very close. We can expect a nesting of concrete. So the other option to make your spacing larger, you can use many legs like this. Anyway. So we talked about something called S spacing between your stirrups. Your stirrups may be open, you may be closed, I don't care. My concern is how many legs do you have? Because based on how many legs, you can figure out what is the area V of your design. The commonly used bars for stirrups are number 3.11 inches square, number 4.2 inches square, only from 1 leg. So how many legs? Multiply it by your area, you can get your area V. Any questions so far? Any questions so far? Okay, how can I design? You told me your stirrups is given. Your distance between or spacing between stirrups is given. So I can figure out what is the design shear strength. But if I would like to calculate what is the spacing, I would like to design from scratch. How can I do this? Okay, we have some steps here. Not sure we have time. Anyway, these steps is very important. You need to follow them exactly. And these are the same steps required in your FE exam for shear. How to determine the stirrup spacing? Actually, draw shear force diagram for your beam using structure analysis method to be able to calculate your ultimate shear force, V ultimate. Second step, calculate the design shear strength of concrete. We have a term here called VC, contribution from concrete. If you remember, VC equal to B web depth square root of C prime, FC prime. So you can calculate your VC, multiply it by phi, you can get this value. Third step, assume diameter of your stirrups. Hey, I will use number 3 for stirrups. And how many legs? Initially, we will assume 2 legs, the minimum. Then I can figure out what is the value of EV. Then, this is not my equations, it's ACI equation. If V ultimate from structure analysis, from your shear force diagram, smaller than or equal phi VC divided by 2, if you found this relationship happened, we don't need any stirrups. Your concrete is enough. We don't need any stirrups in your beam. But we will put the minimum number. No stirrups are required based on ACI. Concrete is enough, but we will put minimum stirrups just in case. But believe me, if your value of shear force diagram smaller than or equal phi VC divide 2, we don't need any stirrups. But if your shear force from the first step greater than phi VC divided 2 and smaller than or equal phi VC, we need stirrups. The spacing between stirrups is the smallest value. We have a value here, we have another value here, take the smallest one. First spacing, AV F yield over 50 B web. This one B web. Or your spacing equal AV F yield over 0.75 B web square root FC prime. Calculate this value, and use the smallest one. If your V ultimate greater than phi VC, please calculate this number, Vs equal V ultimate divide phi minus Vc, and your spacing equal to this equation. So, we need to design our shear reinforcement. We need to design our stirrups. To design our stirrups, actually, we will assume what is the diameter, how many legs, and then we will figure out what is the spacing between your stirrups. To do this, we have some steps. First of all, draw your shear force diagram. Then calculate the contribution from concrete, phi VC. Then assume what is the diameter of used stirrups, how many legs, to figure out what is the value of AV. We have three cases, three situations. First situation, if V ultimate smaller than phi VC divide 2. Say, hey, we don't need any stirrups, concrete is enough, but I will put the minimum number. Any stirrups will be enough. If you didn't put any, that's fine. The second case or second situation, if your V ultimate in between phi VC divide 2 and phi VC, then your spacing between stirrups, this value or this value, what is the smallest one? If you have the third situation, then calculate Vs from this equation, because Vs will be used here to calculate your stirrups spacing. Any question?
Why are we only focused on shear of concrete?
I'm sorry?
Like, to make that determination for spacing, we only use the concrete?
No. We are make reference from contribution of concrete. If your concrete contribution is too much, we don't need stirrups. If your contribution of concrete not too much and not too bad, then we need some contribution from stirrups. If your contribution from concrete so bad, then we need much contribution from stirrups. We have reference, yes, from concrete. If your concrete contribution too much, no need for stirrups. If your contribution from concrete in between, we will add some stirrups. If no, we will add more stirrups.
What is the minimum stirrups?
In another word, what is the maximum stirrup spacing? The same meaning. Is it the same meaning?
Yes.
Yeah?
If you say so. Maybe your design say, hey, your spacing equal 50 inch. Any number is acceptable? No. You have to figure out we have maximum spacing. And the maximum spacing can tell you what is the minimum number you need to put. That's fine. Why maximum spacing can tell me the minimum number? Yes. If you have beam like this, and you figure out maximum spacing 25 inch, so I cannot exceed this number. So first stirrup, after 25 second, after 25 third, fourth, fifth, sixth, seventh, I cannot exceed this spacing. That means this number is the minimum number you can put. That's fine? So it's the same meaning. So if you are asking about minimum number to put in your beam, I will tell you the maximum spacing you have to follow. Okay? So maximum permitted stirrup spacing. Also, we have two situations. First situation, if your V ultimate in between this number and this number, okay, your maximum spacing, the smallest value, depth divide 2 or 24 inch. You cannot exceed. But first, what is the smallest value between this one and this one? Once you get your smallest value, here is your S maximum. Second case, if your V ultimate is greater than phi Vn, second case, from this one, we have two situations. If Vs remember, when you are designing your stirrups, we have this case, and we calculated some term called Vs. Okay? If your Vs smaller than 4b web, depth square root of fc prime, your spacing or maximum spacing smaller of d divide 2 or 24. If your Vs smaller greater than 4b web, d square root of fc prime, your maximum spacing is smaller of d divide 4 or 12 inch. It's more, not complicated, but we need to do more steps. But at least you don't need to remember everything. You have to follow the steps. So one more time. If you would like to design stirrups, you have to follow these steps. First step, draw your shear force diagram. As I told you, right now we are almost to graduate. We don't need to remember everything about structure analysis. Go ahead and put your beam on Risa, get your diagram. You don't need to print it, just draw it on Risa and put it in your homework with your hands. That's fine. And you can tell me what is the value of VR. Then you have your cross section. You have your cross section of beam. So you can figure out what is the contribution from concrete. Go ahead and assume what is the diameter of your stirrups. Number 3, number 4. How many legs? We will start with 2 legs to figure out what is the value of EV. Then you have 2 options. I'm sorry, 3 options. First one, maybe you don't need stirrups, but we will use minimum number. Minimum number means maximum spacing. Or second case, we will use spacing from this one or this one, which is the smallest. Or this case, we have another value of spacing. We need to check your calculated spacing smaller than or equal your maximum spacing. To check your maximum spacing, we have 2 options. From the second option, you have another options. To figure out what is the S maximum, maximum spacing can tell you what is the minimum number of stirrups in your beam. Next time, we will do some examples. We have this example and another example, and then we will start with torsion.